or any individual and say, I want to see all the pictures where this particular individual is there, and the software goes and scans and suddenly creates a folder saying, here's everything with Amitabh Bachchan in it, assuming you have 1,000 pictures of Amitabh Bachchan in it and or your family member. Value for consumer and makes their life significantly productive. This is not some futuristic, requires a supercomputer technology. This is application of existing technology. What this guy did was hooked off a bunch of threads, did image comparison, simple image filtering out, and got the images, and is able to sort out very quickly. There's a variety of people who are doing it. But that's why I want to stress the point that things like multi-core and multi-threading, etc., are not just relevant for significant amount of high-performance computing, but even consumerish applications. The examples I talked about, and games, of course, have traditionally been extreme users of that kind of technology. I won't go into too much detail now, but I saw an interesting tidbit. We heard about the whole Oscar story. Last night I was watching television, and there was on BBC, there was a clip about Cannes Film Festival. I think it opens this week or has already opened. And the first feature which is getting played at Cannes is an animated film, which is quite a bit of a change for Cannes, because they normally do live action movies as the first movies, but this time they're doing an animated film. I think it's a film from Disney, if I remember correctly, and it's in stereo 3D. Right? So now, extreme users of technology in bringing animated film and adding 3D elements to it, and of course all the elements of the characters and story and storytelling is still critical, but taking technology to elements where it is now taking over the top art festivals or movie festivals, which pride themselves to be very non-commercial, art-oriented. You sort of start to see technology entering into those areas also. This is our program, Visual Adrenaline. For people who are really keen in looking at that, there's tools, there's white papers, there's stuff on what we do in that visual computing area. Check it out if you're really keen. Over the next 6 to 9 months, this gets richer and richer and richer as we get to more products like Laravel coming on board. I want to spend quickly some time on how to make all of you productive. Not sure if you guys can read this in the back, but I'll just tell you that basically these are tools which help you derive the maximum performance from your software. In parallelism, there's compilers, there's analyzers, thread checkers, there's thread building blocks, there's math kernel libraries for common math functions. We heard a lot about audio. Audio is a lot of math functions, significant amount of math functions manipulating sound. There's math functions, there's performance primitives, which again allow you to move from generation to generation of architecture without necessarily having to recode and re-optimize. As long as you include the libraries in it and get the latest binaries, you can just load them as DLLs and take advantage of the latest hardware. So incredible tools available to make you very effective in terms of performance. What I'll do is, over the next sort of 5 minutes, I'll talk to you very quickly about another set of tools we're bringing out called Parallel Studio, which will help you plan your parallel application. Somebody asked us a question saying, hey, I'm writing code to my business logic. I don't know anything about parallelism, right? I know what multitasking is, and that's what I do at home and manage work and kids. We know that multitasking. I don't know how to do parallelism. Can you give me a tool which will parallelize my application and I'm done? So that's almost like you're asking as if you're giving me a bubble sort code and you want a response which is quick sort from the machine. How many of you can do that? You guys can write code to do that? Little hard, right? You can't take a bubble sort code and expect the machine to spit back quick sort as an algorithm because there's some funny code somebody's written. That's a little hard. So what we're doing here is guiding you in terms of where to look for parallelism as you start building your applications, right? And that's the sort of the advisor stage, and then help you in the coding stages and debugging stages. Debug is easy, right? Most of us know debugging. We just get to the office. There's no bugs. The bug shows up. 5 minutes, we fix it. We go back home, right? No, right? Debugging is serial code debugging is black magic, at least when I was a coder, that's how I used to think it. Now you have parallel debugging. You have multiple threads of execution simultaneously. God forbid you run into some bug in a 128 thread machine. How do you start debugging that? Right? If you start using your printf techniques and try to debug, we know that's not going to work exactly, right? It's going to be quite some time, and you're going to be sitting there and doing that. So we're putting a whole bunch of tools here to help you debug. I'll quickly flash screens in terms of what these things do. We're not going to go into great detail. If you're really interested in this, we have a booth, we have a presentation on this. You're more than welcome to come and stop by and have a look. Let me show you. This is the parallel composer after the advisory stage. It helps you code and debug. It gives you simple illustrations of what you can do in terms of moving your code from the old style to the new style. Allows a lot of filtering in terms of data to be collected. Many of the tools, what happens is it gives you so much data, you have no idea where to start looking. It's like search. There's so much data you got, you're suddenly worried. So you can set significant amount of filters. It serializes parallel regions as appropriate if necessary. Adds a whole new class of data breakpoints, not functional breakpoints, but data breakpoints. Then we get into verifying phase. Now, verifying is very critical in parallelism, because what happens is you may have written functionally correct code which you debug, but in a parallel environment where there are multiple tasks happening at the same time, you may not be able to exactly predict which thread addressed which variable at what point, and the sequence can get messed up a little bit. So verification is extremely critical. You may have left some critical sections without the appropriate level of controls or semaphores or whatever mechanisms you're using. You may have left them out. The tool starts to help you with that. It helps you potentially identify problems, right? Memory leaks. None of us write code which has memory leaks. We know that, right? We're too cool to do that kind of stuff. Just in case you made that mistake, it will help you potentially identify a memory leak, right? I know most of you don't write code which has memory leaks. So, allocation addresses, in terms of how you get there, because the hierarchy as you go, into deep details, it gets messy as to how did I get there, what threads executed for me to get there. Reference to the source lines always helps, because, and I want to make sure I add, many of you, if not all of you, are users of Visual Studio, from Microsoft. These things plug into Microsoft Visual Studio straight. There's no extra layers of learning which you need to do. This thing plugs in, including the compiler if you decide to use it to derive performance. Data races, something you got to watch out. This will knock us down if you don't understand the data racing condition, especially in parallel environment. Helps you potentially identify data races and thread contention, if you're trying to do variables. And then, of course, the tuning phase where you're really saying, okay, I think I got the logic right, I think I've got the sequencing right, I think I've taken out the functional bugs. Now, how do I get into more performance space? And I talked about integrating into Visual Studio, seamlessly integrates into it, and I'll talk about Visual Studio 2010 also in a minute. Helps you analyze with graphical results how much time it actually consumes. There's a lot more detail behind this. I won't go in terms of processor time, kernel time. I mean, I can give you 3,000 to 4,000 different counters if you really needed to see them behind this to understand what part of the processor is using what. This is details of where is my app spending the time, right? Suddenly you look at this and say, why is this guy spending time on, updating a variable? Oops, I forgot. Just for testing, I had put a delay 1 second in the code. I forgot to take it out, right? And then it points, there's functionally nothing wrong in just saying sleep 1 second or something like that. I don't know if people still do that, and you forgot to pull it out, and suddenly this thing shows you, well, you had put something in there and it seems to be consuming a lot of time. So it gives you intuitive sense of, well, should this particular DLL or function be spending so much time? Maybe, maybe not. This will potentially help you identify those. Opens with source scroll to the hottest line in terms of, for example, if sleep was the problem, then it will bring you there and saying this particular function, this particular line of code is showing. And down to the source lines, not just in the function level, down to the source lines, you can get approximate estimation of how much performance is consumed. Incredible amount of information for you to help